Alright, what's up guys? Cwesolo here, and today we are back for another video on how to code in C#. Last time around we talked about classes, how they work, some object-oriented concepts such as accessors, getters, setters, how constructors work, and how you could overload them to take in different data and stuff like that. We covered all that in the last video. If you missed the last video, there's a card up in the upper right hand corner, and you can go check it out if you want to, if you'd like to go check that out. Today we're going to be talking about abstract classes. We're going to cover a little bit of inheritance. I'm going to actually be doing a separate video on that to cover the topic fully, but just know that we're going to be dealing with a little bit of that today. So let's get into this. We're going to just make an abstract class just straight out, and I'm going to explain kind of what an abstract class is after we go ahead and create one. So creating an abstract class is actually very easy. All you have to do is go here and add a new item. You're going to add a class just like we did in the last video. I'm going to call it shape because I think this is a very, it shouldn't be too hard to make an abstract class. I think this would be a good thing to do an abstract class on, is just a shape, and then we could go ahead and trickle it down from there. So let's go ahead and make shape. That's what we're going to be calling our abstract class today. And it's going to create this nice little class called shape. So to make an abstract class, it's actually very simple. You would just go through, create a class like you normally would, and we'll go ahead and just type in abstract on the name here. So we have now created an abstract class. This class must be extended or inherited from, so we'll go ahead and create another class real quick, and it's going to be just a normal class. We're going to go ahead and create a class. We're going to call it square, or you know what, we're going to create rectangle. So we're going to create a rectangle class, and we're going to go ahead and inherit from shape. So to inherit shape, or to extend from shape, we put a colon and then we type in the class, and no semicolon at the end. Just like that, we have inherited from shape. And now shape, all of shape's methods and variables are going to all be able to be accessed by rectangle. But let's go ahead and go and create some methods for shape, and we're going to go do that right now. So we're going to create a couple of variables, and we're going to talk about protected variables. We already covered private and public, and now we're going to be encountering this thing known as a protected variable. So we're going to go ahead and create two of them, a height and a width. So let's go ahead and do that. We're going to make it int, and we're going to call it height, and actually I'm going to do a capital H. And we're going to go ahead and create width. I'm not sure if I've covered this before, but you can create two variables at the same time by using commas between them. But yeah, so I'm going to explain what a protected variable is. So a protected variable is a variable that is able to be seen by its children class. So if we kind of look at this abstract class here, shape is the parent class of all of its child classes that inherit from shape, right? So if we go ahead and go to rectangle, right, rectangle is inheriting from the parent class shape. Therefore, these variables here are, since they're protected, they're not able to be seen by other classes and stuff like that, but they are able to be seen by any child classes of shape. So if I make a rectangle class, rectangle can see the width and height. If I were to make a square class, it'd be able to see it. A triangle class would be able to see it. A trapezoid class would all be able to see this height and width, right? And they would be able to change them and interact with them. But any other classes that are outside of the sphere of the inherited classes, right? So if you were to take, if we were to have, for example, a set of inherited classes that are inheriting from shape, they would all be able to see these two variables. But any classes that are outside of that set, any classes that are not children classes of shape, they will not be able to see the height and the width. Now we're going to implement a way to be able to see the height and the width and be able to get them, but we're not going to be able to interact with them or change them, right? All right, so we're going to create so basically, real quickly, we're going to create an abstract method, right? Abstract methods can exist within abstract classes, right? And then I'm going to kind of explain what an abstract class is. So let's go ahead and create an abstract method. We're going to create an area method. So we're going to go ahead and put abstract int area. And right after the abstract method, you must put a semicolon at the end, and we're gonna make this a public, so method, if I can spell public right, and actually even better yet, we can make it protected. That way it is unable to be seen by any other classes except for the children classes of shape. So what is an abstract class? Well, an abstract class is really it's instead of implementing something, right? An abstract class can kind of lay an outline, and you could put methods in abstract classes to do certain functions, but abstract classes are always meant to be inherited from. So these classes, this class is not going to work on its own. It cannot work by itself. It must, whatever is inheriting from this is able to use every method that's in here. This abstract method must be implemented on. So when we go ahead and go into our rectangle class here, we are actually missing the area method, and if we don't have it, this won't work. So abstract classes must be inherited from, and they are really kind of almost an outline, and they're really nice when you have to actually, when you're actually going to be inheriting, when a lot of classes are going to be inheriting from a given class, right? So the abstract class of shape, right, there are many, many shapes, right? And all of them can inherit from the shape class, and we can kind of outline what methods need to be there. Don't get it confused with interfaces. We'll be covering that later. But just know that we can actually put methods in the abstract class that can be accessed from its children classes, right? So if we were to put, for example, a getter in here, right? So if we were to go put a getter in here, so we put a public virtual, not bit converter, virtual int get height, right? GHT get height, and we're to go ahead and put that in here. We are able to put these in here, right? We're able to use these, right? And we could use any other methods here. I don't even think we need a virtual thing here, because really, honestly, this isn't going to be overridden. We're gonna make a couple of these things. So we're gonna make another getter. So we're making a public int get width. And we're going to go ahead and return width of the shape. We're going to make a setter that is going to be able to be overridden in case we need to change it, right? So that's what we're going to do. So we're going to go public virtual. So if this needs to be changed, so what this virtual is basically saying is that, hey, this method here is able to be overridden by another class that is inheriting from shape, right? These two are not able to be overridden. You can't override these. But when you have a virtual method, these are able to be overridden. So if we need to override it and change it for some reason in a child class, we can. So let's go ahead and do that. So we're going to go set height. And I forgot to put the int in there, my bad. We're gonna go ahead and we're gonna be taking in an int height variable, and we are gonna basically, actually I meant to make this void, not int. We're not returning anything, my bad. We want that to be void, and we are gonna go ahead and set height equal to our lowercase height. And we're gonna do the same thing for getting the width. So we're gonna go ahead and make it a virtual method again, void set width, and we're gonna take an int known as width, and we're gonna go ahead and set it equal to that. All right. So now we have the width and the height of the shape, right? And these are able to be interacted with. We have an abstract method that needs to be implemented, and these two, if they need to be changed, can be implemented as well. So if we were to make a rectangle, or not a rectangle, a square, we could actually change these and make it so that instead of just using both of these, we can use one of them, right? These can be overridden. So yeah, let's go ahead and do some implementation. So real quickly, we've already kind of extended from shape. All right, we are already inheriting from shape, and we are missing a abstract method. So let's go ahead and do that. So if you go ahead and look at this and you hover over the rectangle here, you can actually show potential fixes. And this is basically what this is going to say is be like, hey, and you need to implement the abstract class method. So we're going to go ahead and implement that, and now we have a protected override on an int area. So as you can see, we are implementing this thing, and yeah, so actually we're going to want to make this not protected. We're going to want to make this public, because we're going to want other variables to be able to access this. So we're going to go ahead and change this to be public, so that way other methods can see, other classes can see it and be able to interact with it, and be able to get the area of the shape if we need to. So let's go ahead and change that, and we're going to go ahead and we're going to get rid of these because we actually don't need these now. We're going to go ahead and change this real quick. So let's go ahead and do that. So yep, it's saying that we need to make it public, so we're going to make it public like that. And we are going to now implement this. So let's implement it. So how do we get the area of a rectangle? Well, it's very simple. You have 2 base times height, and there you go. So that's what we're going to do. So we're going to take height, right, and we're gonna just return height times the width. And as you can see here, we are able to see these variables, and we're able to do some math with them. And that's pretty much how that goes. Yeah, it's very, very simple and easy, and that's really all we need to implement here. We just need to implement the area of this. All the other things are being handled within the abstract class. We don't need to even worry about them, which is very nice. We actually don't need to worry about these 2 things because we have no need to override them. The height and the width of the rectangle are independent of each other, and they can be changed, right? So we actually don't need to do this. And we can even add some more we can actually even add some more things here. If we wanted to, for example, have a circle be able to inherit from this, we can even modify this to do a protected double, and that way we are able to access these things, double radius, and I think that's all we need for circle. And we could make some overloads of this. So we can go, actually we don't even need to. Public, virtual, and we don't even need to do that. We could just simply just make it void set radius. And obviously this would not need to be used by a by the rectangle, right? But to make it work for circles, we can do that. So we can go ahead and make this like that, and we can go ahead and just set the radius. So we can set radius, big radius equal to small radius, and there we go. And for a circle, that would work absolutely just fine. But yeah, so let's go ahead and make another class. We're going to go ahead and make another one. And we're going to make a square, and I'm going to show you how overrides work. So let's go ahead and do that. So we're going to go back up here. We're going to create another class, and we are going to make a square. Right? Square.cs. And we are going to implement from here, from shape, just like that. And we are missing our method once more. So we're going to go ahead and go here, show potential fixes. We're going to implement this, and we're going to go ahead and implement that abstract class. And all the nice thing about circle is we actually don't need to use both width and height because they're both the same. So we can actually just pick one here, and that's what we're going to do. So we're going to just return height. We're going to actually do math.pow because height squared is really what it's going to be doing here. And we're going to just pass in height, just like that. And we are able to, we need to actually put a comma in there. That way it is, I think there's actually a square function in math. Math.sq, no, that's square root. Pound. Height and power of 2. That should work. We might want to take a look at that real quick, what it actually takes in. Oh, math.pow only works with doubles. Okay. That's interesting. So I guess we're not going to be able to use math.pow. I was expecting that to work with an int, but it does not. That's okay. That's fine. We can just go ahead and times height by itself. There we go. Height times height. There we go. Now we're able to get the area of the square. And we're going to go ahead and do another public override on the function get height. So set height. That's what we're going to do. So void set height. And the cool thing is now we are going to be able to just simply use the base here and just set the height. All this is going to be basically doing is we have an override here, and it's just saying, hey, I'm going to go to the base class, which is the shape or the parent class, and I'm going to just run the height and set the height equal to height. Very simple. We can get rid of this if we really wanted to. We can do height equals height, and that works just fine if it's simpler for you to do that, but we can also do base. We'll just go ahead and control Z that. That way, we could just do this instead. So the cool thing is that now we only need a height variable because squares only have the sides are all equal, right? So, and that's pretty much that. These are some very simple methods. So now what we're going to be going and doing is we are going to go ahead and implement our implementation. So we're going to actually take in some input here. I'm going to just go ahead and speed through this real quick. So you guys already know how taking input works. So. All right, so I have finished writing our tiny little code here to get the height and the width of the square, and there is something worth noting here that I haven't mentioned. You're probably wondering, last time around when we were writing our classes, we actually had these things all called constructors. And if you look at the student class, we had a couple constructors, we even overloaded them. But our square and our rectangle classes don't have any constructors. Well, I actually have a very simple answer for this. That's because C# actually automatically gives these things a default constructor. So we actually don't need to worry about it unless we needed to override it for some reason, or we needed to set variables instantly. Well, we actually could make a constructor for these, but I figured for the sake of this video, it's pretty quick to just not do that. So we didn't make any constructors. We don't need to. It automatically does it. But there are scenarios in which you might want to make your own constructors. For example, the student class. So in the student class, we did need a constructor because we were setting stuff here. So we made a default constructor, and we also made overloads of it as well. But here we don't need to do that. We are simply overriding some methods from the shape class, and we don't need to worry about writing any constructors for those classes. So yeah, let's go ahead and run this now, and we're going to put in some input, and it's going to be great. So we're going to type in a height. We're going to do 15. We're going to type in a width, and we're going to do 32. And as we can see here, the area of the rectangle is 480, and its height is 15 and 32. And we could even confirm this by grabbing a calculator and making sure that our math is indeed correct. So we're going to do 15 times 32, and indeed it is 480. Same thing with the square. 15 times 15 is going to be 225. So 15 times 15 in the calculator. Yep, 225. It looks like our math was indeed correct. So yeah, we were able to put input in on these things and store its height and width in the shape class. And we were able to access them and change them from the square and the we actually changed them within the shape class, even though we had no need to override these things, and we were able to set these things. So that's pretty cool. We were able to actually use this abstract class and its methods in its children classes, and we were able to implement that within the rectangle and the square class. And just remember, abstract classes must be extended from, they must be inherited by a child class, and they must, any abstract methods that are in them must be overridden as well. Just a quick recap, virtual methods can be overridden. If it's not virtual, you cannot override it. But if you put the nice little virtual identifier right in front here, you are able to override the method and are able to change it if you need to, as shown here in the square. We just simply did an override on it, and we just set the height. So yeah, and we could even override this further. If we really wanted to change this, we can actually do the height equals height and the width equals the height, and change them both all in one go. And I screwed up there. We could change that here, and we could just set both of those at the same time, and that would be a valid override. So yeah, virtual methods can be overridden, abstract methods must be overridden, abstract classes must be inherited by some other class. And that is pretty much the review for this video. If you guys liked the video, or if you have any questions, please do ask them in the comments. Leave a like on the video, subscribe if you want to learn more about code and game development. I cover all that kind of stuff on this channel. And yeah, I guess I'll see you guys in the next video, and hope you have a great day. Peace out.